Alright, go ahead and copy this figure. This is a little bit harder, and you should recognize this. This is from your benchmarks. And let me show you how to work this. It's not an easy problem, but it's not difficult either. You just have to go through each step. So we don't know how to solve this the way it is, because we don't have a formula for it. But I can cut it into 3 different figures. Alright, so I'm going to cut it here. And that will give me a triangle. I'm going to cut it here. And that will give me a rectangle in here. Now this third figure is another triangle, but these two are the same. So if you remember from the picture, my picture is not drawn the best, but you know it's the same because it's one here and one here, and everything else is symmetrical. So if you find this one, then you know that one. So that's what makes it a little bit easier. All right, let's just jump right into this. Let's find the area for this first triangle, which will be the same as this triangle. All right, figure 1, A equals 1/2 base times height. All right, so now we've got to find this base. Now, the beauty is this base is actually already given to you. It's 10, because from here to here, that's what this means. From here to here is 10. So it's 1/2 times 10. Now we got to find the height. Now that's a little bit of a problem. So let's find, we've got to somehow figure out how to find this height here. All right, now stick with me on this because this gets not complicated, but it gets a little complicated. From here to here is 18. It says it right there. So if I can subtract out this, and I subtract out this, then I'll get what this is. Let me show you how we're going to do this. 18 minus. I'm going to first subtract out this piece here, which is 12. So that gives you 6. So that means here to here and here to here is equal to 6. Now remember what I told you earlier, that these two are the same. So if this is 12 and there's 6 left over, what is each one? Well, each one has got to be divided by 2, which is 3. So from here to here is 3. From here to here is 3. And let's see if that equals up to 18. 3 plus 12 is 15, plus 3 is 18. So that works out. So the height is 3 from here to here. So now let's finish the area for triangle 1. That's 1/2. 1/2 of 10 is 5. 5 times 3 is 15. Now, since this is the same as this, I'm going to add another 15. This is figure 3. So that's 30. So now all we got to do is find this figure, and we add it to 30, and we're done. All right, so let's find this figure. We have the length to be 12. I'm going to do it up here so we can keep track. Area equals 12 times. Now we got to find this side, just this side. Now, here's how we do it. We know that from here to here is 10. Here to here is 1. Here to here is 1, which is the same as this. So I'm going to put a 1 there. So now watch this. From here to here is 10. This is 1, this is 1. So from here to here is 8. And you might say, well, Cradle, this looks bigger than this. How can this be 1 and this be 8? Because I didn't draw it the greatest. That's okay. A drawing is only there to help you. It doesn't necessarily mean this is going to be shorter than this. It's 8, this is 1. How do I know it's 8 and that's 1? Because I just proved it. So don't be fooled by figures sometimes. Sometimes the figures aren't drawn to scale, is what they call it. All right, so now if this is 8 and this is 12, we multiply. 12 times 8 is 96. All right, now we add up 96 plus the 30. 126, and that would be units squared, centimeters squared, whatever it is. And that's how you solve this problem. So it wasn't that hard of a problem. That was on your benchmark. So hopefully on the EOGs we'll get it right.